Hi everyone, welcome to my video lab report of Lab 1 in Physics 2 class at Georgia Tech. I'll briefly introduce to you about the background and the experiments done for this lab. Then I'll go through the details of each experiment and model used in the lab. And along the way, I'll also explain the physics concepts and formulas applied for computation. Firstly, in the first few weeks, we are taught about the charges, electric fields, electric forces, and other concepts. And we're also taught that those concepts are applicable to ordinary and everyday objects. In this lab, we use one of the ordinary objects, which is the common tape, and perform some mini experiments, and we estimate the amount of charge that we on the U-tape that we make. Firstly, we made some observations about the interaction between the U-tape and another U-tape, and we want to determine the sign of charge on the U-tape. After making the charged U-tapes, for the interactions between two U-tapes, you should expect them to repel. If we make both U-tapes in exactly the same procedures, then theoretically, we should believe that those two U-tapes will have the same sign of excess charge. In other words, they should either both gain electrons or lose electrons. So they should be both negative or positive at the same time, and hence those two U-tapes, we should expect them to repel. Next, we want to determine the sign of charge on U-tape, and we do this by using a negatively charged plastic pen. And as a result, we can conclude that the U-tape has positive charge because we observe that the U-tape is attracted to the plastic pen, and they should have different signs of the charge. And since the plastic pen has negative charge, then we can conclude that the U-tape has positive charge. Next, we want to estimate the amount of excess charge on the tape. And in this experiment, we use two U-tapes that we made. We put one at the bottom, which we'll name tape A, and for the other tape, which we put at the top, we name it tape B. There are two important assumptions that we use for simplifying the model. First one is the two U-tapes have the same net charge. We do this assumption because we don't know the charge on both U-tapes. Therefore, to make this assumption, you will see later this will simplify the computation much easier. The second one, we assume all charge on one tape is located at the center of the tape. We make this assumption because, as we all know, the tape is a flat surface and it's not just a single point. And in reality, the charge, we should expect the charge to be spread over the entire surface instead of centered at one point. But in this case, we might have to compute the distance and the directions for each pair of charges, and that could drastically increase the computation difficulties, and therefore it's almost infeasible for us to compute the amount of charge in the object. Therefore, so we assume all charge on one tape is centered as a point, and therefore we now transform the problem into there are 2-point charges and they're both experiencing the gravitational forces. And here, our goal is to determine the charge on the floating tape, which is tape B on the top. And there's a key observation that the momentum of tape B in vertical direction is not changing. From this, we can conclude that the tape B is in equilibrium by the Newton's second law, which states that the rate of change of momentum over time is directly proportional to the force applied and with the same direction. So given the momentum of tape B in y component or in the vertical component is not changing, we know that the net force in the vertical direction is 0. Hence, we now want to find the main vertical forces on floating tape B. We found there were two. One is the gravitational force, which is pointing vertically downward, and the other one is the electric force on tape B that is exerted by tape A, and this is pointing vertically upward. And as we just talked about, The net force in the vertical direction is 0, so those two forces have opposite directions but the same magnitude. Now we come into the computational part. Firstly, we want to determine the gravitational force, which in this diagram is pointing downward in the red arrow. To compute this, firstly we measure the length of the tape, which is about 19.6 centimeters. And as given as information in the lab instructions, we can convert this to mass by the message that a clear tape is about 1 grams per meter. And after we use the conventional formula F equals mg, we can compute the gravitational force of the tape B. And as we just talked about in the last slide, we now also know the magnitude for the electric force, which is the orange arrow in this diagram. Next, we want to apply the formula for electric force, which is on tape B by tape A, and using the next formula, we can jump to the next slide. Next, we want to expand the formula on the next slide. So firstly, we want to use the formula of electric field that is mainly about tape A. Next, we come with our original assumption that both tapes have the same charge. Next up, we have the formula on the third row here, which we can simplify the formula of the electric force. And note that in this formula, we already know about the magnitude of the electric force. And for 1 over 4 pi epsilon naught, this is a constant that we already know. We're looking for QB, which is the charge on tape B. And for D is the separation distance at which tape B begins to float. And this is something that we can measure. And after the measurement, we found that the D is actually about 1.17 centimeters. And after rearranging the equations and substituting the values, we finally had the end result that the amount of charge that tape B carries is 5.41 times 10 to the negative 9 coulombs. And down below is the link to my code, and if anyone is interested in. Next, we have some additional questions. The first one, what if electrons had positive charge and protons had negative charge? What would change about observations you made with your tapes and other charged objects? Firstly, in terms of individual objects, we should see there are fifth of signs for the charged object. For example, if an object has negative sign charge before, then we should see it's now positively charged. If it's positively charged before, then it should be negatively charged now. But if we want to observe the interactions between different objects, we should still see the same observation because we're only flipping the signs. If two objects had different signs of charge before, they still have different signs of charge after we changing electrons to positive charge and protons to negative charge. If they have the same sign, they still have the same sign of charge. And next question, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? If my hand contacts with the charged tapes, we should expect that the charge on the tapes will spread over not only the tapes but also the human bodies. But as one's direct explanation, the human body is so big that we can actually infer that there a lot of charge, the majority of the charge on the tape will just get to the human body, and so the tape is probably very, very less charged anymore. Very less charged, and therefore the tape will lose its functionality in this lab. Thank you very much. Thanks for listening.